Good evening to everybody. Welcome to the InfoSource C Coding Bootcamp. It's our very first week for the evening session, and it's day number 4. I want to today, because the numbers I see here are not so much, I want to customize the welcome. So you welcome Brother Brain Atopone, Daniela J. You welcome. I see Leah, you're welcome. Mary Dakobonsu, you're welcome. Montari Dawuda, you're welcome. Richard, Victoria Dagba, you are all welcome. David, you're welcome. Charles, you're welcome. And so it's day 4 of our week 1 evening session, Coding Bootcamp. All right. Okay, so yesterday we did some great things, but I want to just remind us of the quotes Professor used yesterday. Sometimes later becomes never. Do it now. Sometimes later becomes never. Do it now. So please help me do something right now. Please help me call somebody and inform them that it's time for us to code. Let's code. So please reach out to somebody and let the person know it's time for us to code. So let's do it now. Later, you might never do it. So please, let's do it now. Just please help us reach somebody who needs to be part of this meeting tonight. All right, it's working. It's working. I have 2 more people joining. All right. So yesterday, I remember we did a few things on low-level languages and programming, and we looked at the high-level languages as well. And then Professor helped us to look at the machine code, assembly language, and then we went into it, and we did some little coding as well. And so yes, it's day 4. It's getting more interesting and sweeter. And so let me not take too much of the time, even as we're trying to reach other people. Let me quickly bring Professor on so that we can do some real coding. If you're ready for Professor and you're ready to code, let's engage the chat and say, let's code, let's code, let's code, let's code. Put it in the chat, let's code. I see some people doing something beautiful. They normally take screenshots of what we are doing, and then they put it on their status, and Charlie, it's beautiful. So let's do more of that. Let people know that you are now among programmers. If you're looking for world changers, you are one of them. Professor, you're looking so sharp. Your camera, this is your camera. I need to come and either borrow it or I take it for good. I mean, you're looking so good, and I know that with this smile, there is something in stock for us this evening again. What do you have for us, Professor? Let's get of it.
Thank you all for joining. We thank God for day 4 of the 14-week InfoSource C++ Coding Bootcamp. Today, we are going to continue with our studies and we are going to learn new things. This course is progressive, and so you have to make sure you don't miss any lesson. So anything we will learn, we are going to build upon it. So today, we are going to experience something new, and it's going to be wonderful. All right, I want to share a link in the chat, and that will take us straight to the quiz. Right to it. All right, so the first question is right here, and it says that which of the following best describes the process of C++ code into machine code? Which of the following best describes the process of converting C++ code into machine code? We learned that anytime you write translated into machine code before that code can work. As a programmer, what do we call that process? Is it A, assembling? Is it B, conversion? Or C, compiling? Submit your answers now and let's code. Today we'll be coding something very interesting, and I want to share my slides with you. Let's submit our answers now, and we will we'll be able to do this. All right, so let the answers come in, and let me move this to a new window. And over here we have day 4. Day 4. And today we are going to learn about compilers and translators. Compilers and translators. You can't do programming without this particular topic. You need to understand it very well. I'll give you a quick recap of what we learned yesterday. We learned that programming languages, computer programming languages, are separated into 2 classes. We have what we call the low-level languages, and we have the high-level languages. The low-level languages are closer to the hardware, are closer to the CPU, and the high-level languages are closer to humans. Or you can say the low-level languages are closer to machine language, and the high-level languages are closer to human language. So as a human, which of them would you use to do your programming? I think you'll be using the high level. So when it comes to the high level, we have C++, we have Java, we have Python, we have C#, we have C, we have PHP, Ruby, JavaScript, and a whole lot. We have over 100 high-level programming languages. But then you also have to understand that computers only understand machine code, which we also call object code. And so when high-level language is used, it needs to go through another system. And that system will translate every high-level code, which is known as source code. It will translate it and it will convert it into machine code. So that is what the quiz is about. The quiz is asking that which of the following is the process used to describe, or which of the following best describes the process? So I can see some answers. Some of you have not submitted your answers. Please do that now. I need the answers, and I want everyone to be part of this. This boot camp, if you want to really learn something from it, you have to make up your mind not to just be an observer or someone who is just here to watch what is going on. You need to make sure you participate in everything. Don't be a spectator, be a participator. And that is what will make the difference. That is what will make it the difference. Anything we do here is part of the learning process. So take everything seriously, be part of it. When we are writing code, make sure you write it. Don't just watch what they are doing. No, 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 no. I know this C++ will help you a lot. Years from now, you look back and say that this is where I learned my C++. So I want you to submit the answers. So I'll just give you 1 more minute for you to submit your answers. And let's look at the next slide here. We saw how machine code looks like, and we saw how assembly language also looks like. Assembly language is also low level. In the early days of computing, people had to write entire programs in machine code. Today, almost no one writes programs in machine code. Assembly language, we still have programmers who program in assembly language. And I've already explained all of this, and we learned that the first high-level programming language was Fortran. Fortran, and we learned that Fortran stands for Formula Translation. 1957 is when it was invented. Then we also have the Common Business-Oriented Language, COBOL. It was also invented in 1959. This is interesting. This is interesting. So today we'll be moving on, and if you have submitted your answers, I want you to type this line. I'm preparing you to be a programmer. Just type this line into the chat using namespace std. Just type it in the chat and don't forget the semicolon. It's all part using namespace std. Let me check the answers again and see how many we have. Okay, I'll take it. Let's see how we perform. Whoa. Everyone said compiling, and wow. Now we have assembling, and assembling is also a translation process, but assembling is only for assembly language. So we don't assemble C++ code. The question specifically stated that C++ code. When it comes to C++ code, we do what we call compiling or compilation. So the answer is C, which is compiling, and you've all done so well. I'm taking you to the next question. And the next question says that any code written in a high-level language is known as source code. Any code written in a high-level language is known as source code. A, is it true? B, is it false? C, if you're not sure, you select C. So you see a pop-up on your phone asking you to change the question. So change, move to the next question, and please submit your answers right now. I'm waiting for the answers. And let me check how many are using namespace STD. And wonderful, I'm seeing Leah, I'm seeing Brain, I'm seeing Montari, I'm seeing Meridakon, I'm seeing Solomon. All right, so just type using namespace STD, just put it in the chat for me, and let's code, let's code, let's code. If your chat is not working, type it in WhatsApp, type it anywhere, let the world know that you are doing programming. All right, did you know that coding is not hard to learn? Did you know that it is not hard to learn coding? If you take the time and have a lot of patience, you can really learn just about anything. Coding is no exception. Learning to code takes a good amount of time and persistence. But if you have those already, then we guarantee you will get there. This is from careerkarma.com. And it says that if you can be consistent and persistent, you are going to learn coding and you are going to be good at it. Sometimes you watch movies and you watch YouTube videos and you see people coding, and you think that coding is only left for the white man. How can a black man be doing coding? Let me tell you, all those things are wrong. They are wrong perceptions and wrong ideas. You can be a programmer. You can write those codes. You just have to learn them. But what it takes is consistency. And so this boot camp, I don't want you to come day 1 and come day 5 and come day 9. It's not going to help. Make sure you put in the time, invest this time. And this is going to make you a programmer, and it is going to make you more valuable. And you will know that the time you put into this is really worth it because you are going to reap from it. All right, let's see how we did. And we have 75% saying, yes, it is true. We have 13% saying it is false, and 30% are saying they are not sure. All right, today's lesson will give us the answer. This is myself, your humble servant. My name is Darlington Fadams, and I'm the founder and president of InfoSource Technology Institute. For the past 17 years, I've been working in real companies, working on real projects, working with real customers, developing real applications, and solving real problems. For the past 7 years, I've been working full-time as an IT lecturer. I've been teaching IT, I teach Office, I teach networking, I teach graphic design, I teach web design, I teach cybersecurity, I teach almost every known area of IT. So for me, IT is what I do. I also love to draw, and so I have a YouTube channel dedicated to my drawings. When you click on this link, it will take you to my drawing channel, and if you get time, I want you to watch one of my drawings and write a comment and subscribe. I have a motivational message for you today, and it says that never give up, because great things take time. Great things take time. And so never give up. This programming we are learning, you will not know it in one day. You will not know it in just a single day or by attending a single class. You have to understand that it will take time. We are giving you 14 weeks. If you can put in that 14 weeks to complete the boot camp, I can assure you that you'll be a programmer. In life, greater things take time. And so don't think that everything will just happen all of a sudden. Life was not designed to happen all of a sudden. Every great thing takes time. And so don't give up. If you are working on something that is part of your dream, something so important to you, and you are going through challenges or things are being difficult, don't give up. Winners never quit, and so don't quit. And quitters will never win. Some people will start one thing and they'll be so excited about it, but in the middle they'll stop and they'll start another thing. They'll be so excited about it. In the middle they'll stop again. They'll be so excited and they'll stop in the middle. And so when they check their life for the past 10 years, they've never completed anything. They've started many things. They've joined many things, but they never completed even one. It's not about starting. It's about finishing. And so if you don't give up, I can assure you that you will get there. So never give up, because this is great and it's going to help you. Today's lesson is about here you can see high-level programs moving through a translator and producing an output, which is a low-level program. And you can see that the low-level program is ones and zeros. The low-level program we are seeing is ones and zeros. You can see under the translator that there are 3 types of translators. Today, we are going to see the CIA of translators. And this is not talking about the United States Central Intelligence Agency. It's talking about compilers, interpreters, and assemblers. These are the 3 translators used in computer programming. In C++, we are more interested in compilers because C++ is a compiler language. And so this lesson is titled Compilers and Translators. What is a translator? What is a translator? A translator is a programming language processor that converts source code into machine code. Simple. It is a programming language processor that converts source code into machine code. Machine code is also known as object code. So it converts source code to object code or machine code. Listen, any code written in a high-level language is known as source code. So this takes us back to our quiz, and the quiz said that any code written in a high-level language is known as source code, true or false, and you can see that the answer is true. Any code written in a high-level language is known as source code. However, computers cannot understand source code. Before a computer can understand and execute it, source code must first be translated into a form which the computer understands. This form is called object code or machine code. Now, this is the foundation of programming. If this doesn't make sense to you, then you have not started learning programming. So this needs to make a lot of sense to you, because all the languages we are learning, they need to be translated before computers will understand. Let's take for instance, the President of the United States wants to communicate with the Prime Minister of India. And the President of the US only understands English because English is their first language and their only language. In US, they only speak English. So he only knows English, but the Prime Minister of India does not understand English. Let's say the Prime Minister of India is the CPU, and the President of the United States is the source code or the programmer. How can the President of US communicate with the Prime Minister of India? Of course, he has to communicate something very important. He's not going to say that because he doesn't understand English, they are not going to communicate. He will not say that. What do you think he will do? He will get a translator. And so when he speaks, he will speak to the translator who understands English and also understands the Indian language. And the translator will speak to the Prime Minister. When the Prime Minister is also replying, the Prime Minister will speak to the translator, and the translator will also speak to the President of the US. This happens a lot. If you watch UN meetings at the United Nations, you see that almost all the leaders have earphones. So when they are sitting in meetings, they have earphones. And those earphones, do you know what is happening? We have translators in certain studios who are listening to everything and translating into their own languages. So all those presidents, the Turkish president, the Israeli prime minister, the all those heads of state, they are all hearing the same message in different languages through the headphones or the earpiece because they are translators. In computer programming, this is what is done. The umbrella term is what we call translation or translators. Under translators, there are three categories or three types. It says that generally there are three types of translators. The first one here is assemblers. The second one, compilers. And the third, interpreters. They are all translators. So which one is assembler? An assembler is a translator that is used to translate assembly language. We talked about a language called assembly language. Assembly language is not machine language. And so even in low-level assembly language, the code needs to be translated into machine code. And so what type of translator do we use to translate assembly language? If this appears in an examination, you have to understand that since we are dealing with the assembly language, you need to use what is called an assembler. Later, you can read more about assemblers and you can see how they work with different CPU architectures. But machine code is a much lower level language than assembly language that can be understood directly by the CPU. The purpose of an assembler is to translate assembly language into object code. Again, object code is the same as machine code and is the same as machine language, is the same as binary. So watch this picture here. This is what we call the low level and the high level. Over here, we have machine code, which is the lowest level. And this is a CPU, the hardware. The CPU is what processes all the instructions. And so it is only machine code that can communicate with CPU. And so if you're a programmer and you want to program at the lowest level, you need to program in machine code. But that one, just forget it because no one is programming in machine code. And so if you want to go as low as possible, you need to learn assembly language. Once you learn assembly language, you need an assembler, and assembler will convert or translate, the word is translate assembly language into machine code before machine code will communicate with the hardware. If you want a higher level, you see that the CPU is at the bottom, is low, but the highest ones are these ones here. these are the high-level languages. So when we say high level, this is what it means. It doesn't mean it is advanced. It simply means it is higher or far from the CPU, or far from hardware, or far from machine code. So over here, we have C++, we have Java, we have Python, and all these powerful languages. When you write in this language, you need two types of translators. We have the interpreter and we have the compiler. Python doesn't work with compilers. Python works with interpreters. Java works with compilers. C++ works with compilers. And so, depending on the language you are studying, you need to know whether you will use a compiler or an interpreter. But when it comes to assemblers, assemblers are dedicated to assembly language. What is a compiler? A compiler is a translator. It is also a translator that converts entire source code of some high-level languages. I say some because not all high-level languages, because some of them work with interpreters. So it converts the entire source code of some high-level languages into object code or machine code. Same thing. Now, I said entire here, and this entire word I put here is very important because when we talk about compiling and we learn about the technicalities of compilation, you will understand that compiling doesn't compile part of the code. If you learn about interpreters, interpreters interpret the code line by line. And so for a program to run, the interpreter will interpret one line and produce a result, then go for the next line and produce a result. And so if you are running an interpreter language, half of your project can show on the screen and half will fail because the error was met in the middle. But with compilers, compiles everything. And so if there's an error anywhere, the whole compilation will fail. And so once the compiling is done, it means there's no error and it will work. And later we'll learn about certain types of errors because some errors are compiling errors and some errors are just logic errors. All right. A compiler takes a source code as a code all in one go. This process is called compilation. And so when they ask you to differentiate between compilers and translators, and interpreters, the first thing you say is that compilers compile the source code as a whole, all in one go. But interpreters work in a different way. When it comes to compilers, if errors are found in the code, the compilation will fail and the program cannot be executed. Once compilation is complete, the translated program file can be directly used by the computer and is independently executable. Programming languages like C, C++, and Java use compilers. So if you are supposed to give examples of languages that work with compilers, you have C, you have C++, you have Java. Okay, one more thing about compilers. And you can see that this is your source code. This code will go through a compiler before it to become machine code. Yesterday, we learned that C++ is not really understood by computers. Computers only understand this. So why do we program in C++? We program in C++ because we are going to submit our code to a compiler, which will translate our code into machine code. Later, we will learn about some of the popular C++ compilers out there. We'll talk about that later. But what is an interpreter? An interpreter is a translator, is also a translator that translates source code of some high-level languages into object code, one instruction at a time. So you see that I highlighted this. This is where the difference comes in, one instruction at a time. Translates everything in one go. It translates one instruction at a time. Last time I gave an example. Okay, over here it says it is similar to a human translator translating what a person says into another language, sentence by sentence as they speak. The resulting object code is then executed immediately. So I give examples of two teachers. There's one teacher, when he comes to class, do you know what he likes to do? He likes to take everyone's questions. So he will ask everyone to tell him their questions. And he will wait and receive all questions. Then he will take his time and give answers to everyone. We have another teacher. He doesn't like that at all because it disturbs his brain. So what he does is that he takes questions one at a time. Ask your question, receive your answer. Next person, ask your question, receive your answer. Next person, ask your question, receive your answer. At the end of this lesson, I'm going to ask you to tell me whether teacher A is a compiler or an interpreter. And also, teacher B, is he a compiler or translators? Sorry, or an interpreter. All right. So if you look at the process of interpretation of the interpreter, it is called interpretation. Programming languages like Python, JavaScript, Ruby use interpreters. And you can see that they work one line at a time. One line at a time. All right. Now, comparing compilers to interpreters, it says that compilers scans an entire program and translates it as a whole into machine code. Interpreters translate program one statement at a time. Compilers, the execution of the program happens only after the entire program is compiled. So if the compilation is not done, you can't execute the program. But when it comes to interpreters, the execution of the program takes place after each statement is evaluated. Wow. Immediately each line is compiled, it shows the results. Compilers, all the errors are shown at the end of the compilation, and the program cannot be run until error is resolved. So when it comes to compiling, it will compile the whole code and list all the errors it found. Until you resolve all the errors, nothing is going to start. Again, we have errors that are syntax errors. That is errors in the coding. You didn't code the right way, you get an error. We also have logic errors or logical errors. These logical errors are not syntax errors. They are errors that are just logical. What it means is that it will compile all right, but the way it is working, that is not what you intended for it to work. So it is a bug, it's an error to you because even though it's working, it is working in a different way than you expected. So that is a logical error, and that one will not fail because to the system, it is correct. All right, interpreters display the errors from line to line. The program runs till the error is found and proceeds further on resolving. All right, so with interpreters, any line that is approved will be published. When it meets an error in the middle, then it will stop the program. That is different from compilers. With compilers, we store the machine code, stores machine code in the disk storage. This one, machine code is not stored anywhere. Compilers program run faster, interpreters run slower. All right, so this brings me to the end of my explanation of compilers and translators and assemblers. Sorry, compilers, interpreters, and assemblers. They are all translators. So when you say translators, you are talking about all these three: compilers, interpreters, and assemblers. This is extremely important. That is why we are taking time to talk about them. So let's delve into coding and let's do some coding. Let's do some coding. At the end of the coding, I'm going to ask you to tell me whether teacher A is a compiler or teacher B is a compiler or an interpreter. So we are going to use Visual Studio Code, and we are going to write our code. Today, I want you to see code in one particular way, and I want you to follow it and let it make sense to you. And I want to just use some few lines of code to design a simple game. And I want you to see how everything works. And as you follow the code carefully, it will help you gain understanding of how C++ works. So I'm going to select the language here, C++, and let me save my work. And today is day 4. I'm going to call this guess game. So guess game.cpp. I didn't say girls game. I said guess game. So make sure you don't bring spaces in the file name. When I talked about spaces, I was just talking about how the file is named. Just call it guess game with no space, .cpp with no space, and then save it. So it's a game that is going to help you to guess. It's going to be an interesting game because we are going to tell the computer to generate a random number. And when the computer generates a random number, it will keep it in memory and ask you to guess the number the computer generated. If you're able to guess it, then you win. If you're not able to guess it, then you lose. We can make the game more difficult by increasing the range of the numbers. So we'll start with 1 to 10. So you just have to guess between 1 and 10. So that is how we'll start. That's an intermediate one. If we want the game to be very easy, we can do, let's say, 1 to 3 or 1 to 5. So you just have to guess between 1 and 5, which number the computer stored in memory. If you're able to guess it, you win. If we want to make the game more difficult, we can do 1 to 30. And that means you have 30 options. All right, let's start and let's see how this is going to go. So watch this. I'm going to do #include again. And my IOStream is right here. 95% of all C++ programs will work with this IOStream. Later, I don't know if it's tomorrow, we'll be talking about header files, and I will explain this IOStream and let you understand that this IOStream is actually a file. It's a file that you are including. It is a header file. So you see just like this IOStream, you don't see any extension or anything, but this is a file sitting in your compiler. And it is like a library. And when you include it, it brings a lot of features into your program. Without this, cout will not work. Without this, cin will not work. Without this, endl and other objects will not work because they are all defined within the IOStream. Also, we will be using namespace std. Now, this using namespace std, yesterday I explained it, but I'll be explaining it again. This namespace here is also defined in the IOStream. If you don't include IOStream, using namespace is useless. For example, if I come here and I start my int main, and I come here and I say cout, welcome to the number guessing game. And I say endl. Now, we can see that cout has been recognized because the color has changed. Endl has been recognized. Endl has been recognized. Now, when I remove this, you see that they will not be recognized anymore. I told you this yesterday. Once you remove using namespace, they will not be recognized. So if you run your code, you are going to get serious errors unless you attach the namespace here like this before they will be recognized. So this one is recognized, but these ones are not. You need to do the same. To avoid doing all of that, you can just include this using namespace std. But this using namespace std, this std comes from the IOStream. If I remove the IOStream, your using namespace std will also fail because it doesn't make any sense right now. You see that cout is not highlighted. It's now color white. Endl is not known. This is also not known because they all come from the IOStream. So this IOStream is very important. We are going to talk more about the IOStream. I'm also going to include other headers right now, like #include. I will include my CSTD library, and I also include another header that will help me with time. And this time I'll use it to generate the random numbers. All right, so we'll start here by clearing our system CLS, semicolon. Then what I'm going to do here right now, I'm going to generate the random numbers. So I'm going to write 3 lines of code that will generate and store the random numbers. So watch this. I'll use srand. You don't have to understand it. Just you type the same thing when you are creating yours. The only thing you need to know is that is a code to generate the random numbers. So srand is like a generator, and it is using time to do the generation. And time, we are working with the millisecond. So because millisecond changes every millisecond, the time will change every time. So srand, what it does is that it is able to pick a number and randomize the number to become another number. So we are passing the time into srand, and srand will use it to create a random and generate a number. Now, we are going to store our random number here in this variable called random num, and we are going to say that random num should be 1 plus rand, like this, modulus 10. So what it means is that this is a code that will generate the numbers between 1 and 10. If I want to make the game easy, I'll just come here and if I want the game to be more difficult, I can make this 30. It means generate numbers between 1 and 30. So that is what this means. And when it generates a number, it will store it in this variable. Let me use one. I'm also going to ask the user to input. So I'm going to create another variable and let the user input. Later, we are going to learn all about variables. Without variables, you can't do programming. So we are going to learn about variables. Now, over here, let me create my cout here and say that this computer has generated a number between 1 and 10. I'm telling the user this, that this computer has generated a number between 1 and 10. Okay, let me decorate this code by putting some dashes here so that my code will look a little bit decorated. And let me bring another endl. So if you have questions, you can ask when it's time. And you can see that anytime we use cout, we are sending a message to the screen. So here, I'm going to tell the user to guess the secret number. I wrote this code some time ago, and I told my users that if you fail, someone will die. If you win, you save a life. So before you choose, think harder, very, very hard before you choose, because if you choose a wrong number, someone is going to die. Your job is to guess to save a life. If you guess wrong, someone dies. All right, so this one I'm not going to make it look that serious, fatal like that. So all I'll do is that I'll tell you to guess it. And when you guess it, I'll tell you that the secret number you guessed or you are supposed to guess is this. it is the number stored in this variable called random num. Again, we'll be learning about variables, and all of this will make sense. So the secret number is going to be stored here. After you enter your number, I'm going to tell you the secret number. Then I also tell you with another cout and say that the number you entered is this, and I'll tell you that you entered input num, because what you are going to enter, I'm going to store it in another variable called input num over here. So when I ask the user to guess, I'll take what the user guessed and I'll store it here. And I'll tell the user what he entered. Now, I'm going to say something here that if the user is right, the only way I can tell the computer to check is that if the input num, remember, input num is what the user entered. If input num is equal to random num, that means if what the user inputted is the same as a random number, then it means the user did well. So let's tell the user something. We'll tell the user that, wow, you got it. So here, I'm not saying you saved a life. Wow, you got it. Else, let's tell the user that, I need to see out and say, oh no, wrong guess. Let's endl. Endl means endline. Now, after the user guesses wrong, we want the system to allow the user to play again or try again. So I'll create a system pause here, and I will come back here and say return to main. So the system pause, what it will do is that, it will ask the user to press any key to continue. Once he presses any key, then we will launch this code. That is return to main. Return to main means come to the main function here and start running the code again. That means I will replay or allow the user to play again. Let me run this code for you to see. And if it is working, we should see the game on the screen. Welcome to the number guessing game. This computer has generated a number between 1 and 10. What is the number? So this is a game anyone can play. Let me put in 4. And it says that the secret number is 2. The number you entered is 4. Oh no, wrong guess. So you see how programming is. All the messages that will be displayed on the screen, the programmer will put it in his code. Now it is asking me to press any key to continue. When I do that, it will refresh the game and allow me to play again. Anyone can play this game. Let me give him 7. Whoa, you see I got it? The secret number is 7. You entered 7. Wow, you got it. So the computer will never cheat you. Once the game starts, the computer has picked the number. It's in memory. You have to think and get a number. Let me put 3. Okay, I missed it. The computer chose 5 and I entered 3. Let me try again. I'll put 6 now. No, the computer selected 8. The secret number is 8. But you entered 6. Now the dashes I put there, do you see what the dashes did here? So it has helped me to decorate this in a way. Sometimes you can use these symbols to decorate your console app. Okay, what is the number? Let me give it 9. I missed it. Let me try again. 6, I missed it. 5, I missed it. 4, I missed it. 3, I missed it. 2, I missed it. 1, let me try 10. I missed it. 9, I got it. So this game, you are going to develop it and you can play it over and over and over and over and over and over and over again. All right, so this is what we are working on. And this is a simple code. This hash include IOStream. It's including our header file called IOStream, not ice cream, IOStream. Then we have another header file here called cstd live. So just put it in as it is. And then we have another header called CTime. Then using namespace std. Now, most C++ programs will only work with IOStream and using namespace. These other header files, like this one, it is controlling the timer. Sometimes when you are introducing certain features, you need to introduce certain headers that will make those features work. So these two, they are all working with the random system and the timer. All right, so that is it here. Using namespace std, I'm sure we'll go into details tomorrow because std is a namespace. Then int main is our main function. Every C++ software needs a main function. It is a home page of any C++ software. You can create other functions, but the main function is the main one. It's the main function you need to work with. So you need to understand that we have main function. System CLS here means clear the system screen. So it's just an instruction telling the CPU that I don't want to see anything on the screen. Before you run my code, clear my screen. Then srand here is generating the random number, and it is calculating the random number and depositing it here or storing it here. Then this is a variable we have created down so that later when the user enters their number, we will store it in this variable. So here, when the user entered the number, we collected it and stored it here. So cin is used for storing. Insertion. Cout is used when you want to output a message. So it says that the random number is random number. So that means whatever is stored in random number. The number you entered is from input num. Now compare if they are the same. In C++, we use double equal sign to compare. We use single equal sign to assign. So if I come here and I create an int variable and I say the int variable is called x, and I say x is equal to 2, what I have done here is that I have stored 2 inside x. That's what I have done. But if I say that if x is equal to 2, I'm not storing 2 at all. I'm only comparing. I want to check whether whatever is in x is the same as 2. So sometimes we do comparing, and when you are comparing, you use a double equal sign because we are not storing anything. We are just checking. If input num is the same as random num, show us, wow, you got it. That means if the number the person selected is correct, tell the person you got it. Else, tell the person is wrong. All right, so we've tested the game and we've seen how it's working, and we are done with the code. I'll be sharing the code with you all, and you'll see this and be able to practice. But then if you have any question, I want to hand over the class to the moderator, and we can receive our questions and prepare and end the class. So thank you very much. Thank you.
Thank you, Professor. So this has been the guest game coding we just did, and it's working as well. It's working. Professor, you said guest game, but perhaps that we could think of something girls game. I don't know how it would be, but we are programmers. So maybe Sister Mary will help us to develop the girls game and then tell us what we should include and what we should take out. Anyway, that's just on a lighter note. If we have any questions, if there are questions, let's receive some too. It's 8 o'clock on the dot. One will be time conscious, and so 8 o'clock on the dot. Let's do some 5 more minutes and then we'll be out of here. So if you have any question, please, you could raise your hand and then we'll allow you to ask your question, or there's an input, you can just go ahead and make it. Brother Peter, please unmute yourself and then you can speak.
Hello, good evening once again.
Good evening.
My question is, when he was using, you see, he gave us two options. He says if you using the name, using the number space std at the end, he used semicolon, but when he used the other option, he does std colon colon. So I want to know if it will cause any error or something.
Professor, please, do you get what he's saying?
Right, so let me just explain this. If you want to append the std to the object, this is how it is done in C++. You see, in a different programming language, you may do it in a different way, but in C++, we type the name of the namespace. Because it's a namespace, you type it and you bring colon colon. That is how namespaces are attached to objects. Including it at the top here, you just have to type it this way. That is how the language works. Peter, I can't hear you. So that is how it works. If you are adding it to the C out or the C in, you need to use a dot dot because that is how the C++ language works. In programming, you need to follow how the programming works. How that particular language.
I get it.
All right.
Thank you. Let's have Mary Daco. So Mary, can please unmute and then you talk to us.
Good evening to everyone.
Good evening.
Yes, I wanted to ask Professor that for today, when I entered my end line, it didn't change color. Is there something I did wrong?
All right. So NL will not change color if using namespace std is not properly placed here. If this is not properly placed here, NL will not change color. And also, if you forget the left shift operator, NL will not change color. So check the left shift operator here. This one, I'm sure you missed it. So check and see if it's there. NL should
I have
work.
it there. I have it there, but one thing I saw today too is at the hash include, there's this red line under all of them. The hash include CSTD library, the hash include CTime. All of them has some red line under. I don't know, that might be the cause of the end line. I don't know, because I have that operator.
So save your work and try running it. If it doesn't work, close the Visual Studio Code and open it again and check. Sure, it should be fine. But if it doesn't work too, let me know and I'll let you try something.
Yeah, and for your screen, I can't see the rest, but it's just I just typed only 23. Then I think your screen went off, so I can't see the rest down for me to run. What about that?
Okay.
Without that, I can't run.
Well, if where you've ended doesn't have any error, it should work. But then, if you can add.
No, I got to the if input.
So just I'm showing it now.
Equal sign to.
Yeah, I'll be happy if you can just add it. I'm showing it now.
Okay. Let me switch it so that someone too can access or a question. And I'll go off. So I'll come back again.
All right.
I'll go off. And
so let's receive David. Brother David Akwalu, please unmute and then you can ask your question.
Yeah, good evening. House.
Good evening.
Yeah, Prof, I also wanted to find out at what point do we use the double end L, and then at a point you also use a single end L in the lines.
Okay.
At what point?
All right, so I get you, and let me just explain. Let me just run it, create a new program and use it to explain it. So I'll just start by doing #include IOStream and using all right, so here, let me write a C out here and say, hello world. And here you see, I'll just put my ender here. Now, I want to create another C out here and say that my name is this, my name. And over here, I want to put another C out and say, I am a C++ developer. All right, over here. And now watch this. I'm going to run this. Let me save this work as, let's say, endl tests. Now, I've saved this, okay?
Okay.
And also, I wanted to tell Mary that if your file is not saved, some of the objects will not be colored. So after saving, before you see that the colors will show. Okay, let me run this and you will see. So, Mr. Akwalu, you see right now that we have hello world. Okay, let me clear the screen so that it appears very well. So system CLS so that you see it well. Okay, so with system CLS, the screen will be cleared. Now watch this. You can see that each statement is on its own line.
Okay.
It's on a line. That is what the endl simply means. It means that when I place endl after hello world, it means that end the line. Simple. So the next statement start on a new line. Now, let me add another endl here. Now, to add it, I have to do it before the semicolon. Watch what will happen, and you yourself, you get an answer. So once I place double endl, just tell me what you see now. Tell me what you see now.
So
you can't see
yeah, I've seen I think an empty line in between the hello world and my name is Darlington.
Okay, good. Now let me add another one. And let me run it again and you'll see something. Now what do you see?
So now it has become like double space line there.
Exactly. It's just like in Microsoft Word, pressing enter.
Enter.
How many lines do you want? How many new lines do you want? Any new line you want, NL will give you a new line. Watch this. I'm going to clear all the endls here and see what will happen. I'm going to clear all the endls and you see what will happen. So watch what happened here. What do you see?
So now hello world just comes after my name is Darlington. There's no space.
So I didn't give instruction to end the line. So you see that the next statement joined it.
Okay.
So you don't want the next statement to join a previous statement. You just have to bring endl. Endl means move to a new line. And it also means end the current line.
Okay.
Another symbol we use is called /n. /n means the same thing. So I can put /n here, but /n needs to be in the quote. When I run this, see that it will work just like endl. So you see that it has moved it to the next line. Have you seen it?
Yes, please.
I can add another one, and when I run this, you can see that we are going to get it 3 times, just like the endl we saw. So the two do the same work. You can see it right here, right?
Yes.
That is why sometimes I'll use 1 or 2 because I want my program to appear well to the user. You see, when you are developing a program, you think of the user interface. We call that UI. So in programming, we have UI, we have UX. UX stands for user experience. So you make sure that your program gives the user a greater experience, but then the interface, which is a UI, you have to make sure that it looks okay. Now, who told me to bring all these dashes here? No one did, but I knew that bringing those dashes will let my game appear a little bit nicer. You see what the dashes did?
Yes.
So it's just about UI, making sure the interface looks a little friendly. And I think the dashes, I should remove one from it and see. Let me clear one. And when I run it, I think it will look much better. So that is explanation to the end though. Thank you very much.
You're welcome, Prof. Thank you also.
All right, so it's 8:12 p.m. and okay, Mary just got on the line. So okay, Mary, please unmute yourself and then you can talk to us. Oh, sorry, I rather muted it. Allow. So unmute and you can
Okay,
talk to
Prof.
us.
I saved the work. Yes, I'm back. Prof, I saved the work and then I ran into error. And checking on my error, I saw one at the line 18, the SIN input number. SIN input. I don't know what I did wrong there, but it said there's an error there. And then also at the line 23, it said if input equals to random number. I just thought that maybe I typed.
We all see it.
Random number. Let me see.
Would it be possible for you to share your?
Yes, yes. I've seen where the problem is. Where is it? Where can I show? Please, what do I do? I take the video on.
Are you? It's on laptop.
Please, my camera is disabled.
Okay, wait. You don't have to use your camera. Are you? Is the Teams running on your laptop?
The team is
Please.
run on my lap. No, on my phone.
Okay. Then you have to turn on your phone's camera. And all right. So
My phone's camera is on.
it's disabled, eh? Okay. I think I've
Yes,
allowed your
please.
camera. Try it. Let's see. Excellent.
Okay, I have to turn it this way. Okay, Prof. So this
Brilliant.
one, the screen for the error. This is what I got for the error. Line 17, 18, and 23.
Okay, so just hold on. Let me check what the error is. So line 17, sometimes the error on line is line 16.
And Prof, I saw that I did not bring the end line inverted comma, the comma at the end. I saw that line 17, I didn't bring it there. So I just placed it there.
So now you have done it, eh?
Only that
Now
one.
you've done
But the
it.
23, I don't know. Yes, but for the 23 and 18, I don't know what the problem is.
Okay, so 23 is it called random num? Okay, see out. Okay, so okay, now the random num is a spelling mistake.
Yeah.
If check this random num and go up to where you declare the random num, move up. The random num was declared somewhere. Move up. And
yes,
check the spelling.
The
if they are the
random.
Yes,
now it's the same. It's the same.
It's the same. Okay. Okay. Move to the right a little bit. Good. Okay, you've gone too much. Okay. Okay. Move down a little. Okay. It says random num. You see that there's a spelling mistake. I told you that there's a spelling mistake. I can see double
Yes,
D.
Prof, I've seen that one. Double D there. So I changed it as you told me to go up to check on where I declared it. I came down now to delete the D here.
Exactly. So if you have done it, you just need to run your code again. Run it again after correction. Save first. Save first before you run again. Because when you run again, it should not display the errors.
I've saved it and I've clicked on the this boy. Yes, it says the computer Prof is working now. Thank you very much.
So this is how we learn coding, okay? In programming,
okay, Prof.
You're making 1,000 mistakes. They are all part of the learning process. So thank you very much. God bless you.
Thank you, Prof.
All right, so thank you very much for those beautiful questions. And I think we are 17 minutes away from our 8 o'clock deadline. So we want to call it a night. Today is day 4 of the first week, which is the free trial week. From next week, we're going into the paid system and it will be prepaid. And so I want to encourage you. We normally share the details of payment on the WhatsApp platform. So you could pick any of those numbers, whether the MTN or the Vodafone Momo numbers, and you could do your payment. Either you are doing for only week 2 or you want to pay for week 2 all the way to week 14. And that one, I would recommend it because it's just a one-time payment and you just relax and be joining all the meetings. Very important. But if you'd have to be doing the weekly one too, you're welcome. Let's do it. The recordings for this week, I'm sure everybody's able to access them once we share the link. And so right after this meeting, the recorded link will be shared again. But from next week, then a session, if recorded and you request for it, is going to be 5 cedis. And then if you want to do for the whole week, which is 6 sessions, instead of a 30 Ghana cedis, you pay a 20, and all of the links to the recordings will be shared with you so that you are abreast with everything we are doing. And so, Prof, let's have a final word and then we can sign out.
All right. So again, there are 2 teachers. When teacher A comes to class, he wants to receive all questions and note them down. And he'll take his time, about 30 minutes, and speak to all the questions at a go. Teacher B doesn't like that at all because it hurts his brain. So teacher B wants to receive 1 question at a time. So you raise your hand, he'll call you, you ask a question, and he will answer you. Then he'll ask the next person, and the next person will also ask their question, and he'll answer them. Now, my question is teacher A a compiler or an interpreter? And teacher B, is teacher B a compiler or an interpreter? If you know the answer, raise your hand and let me call you. In just 5 seconds, we will do that. So Mary, let me enable you right now. Go ahead and unmute yourself and tell us the
Teacher
answers.
A is a compiler because he takes all questions and then answer at once. And teacher B is an interpreter because he takes the questions one after the other, one and answer, one then answer. So he is an interpreter.
All right. So Leah, Leah, let me hear from you too, and I'll tell you what I have to tell you. Unmute yourself, Leah.
Okay. I was going to say the same thing as Mary. She beat me to it. So the teacher A is a compiler, as she said, and teacher B is an interpreter.
Wonderful. Your voice sounds like someone I know. And All right. So teacher A is a compiler, teacher B is an interpreter. So keep that in mind.
Yes.
Don't forget what we've learned. Tomorrow we have something great to learn. So let's keep learning. Just dedicate this 1 hour to learning programming. And I tell you, this will change your life forever. So thank you all. God bless you. Enjoy the rest of the night. And I'll see you tomorrow.
Thank you.
So thank you.
Thank
See you
you.
tomorrow, same time, 7 p.m. to 8 p.m. Please keep on spreading the good news that the InfoSource C++ Coding Bootcamp is ongoing. It's still not too late for somebody to join. I believe strongly that once they want to, they can, and they will do very well. So please have a wonderful night and sweet dreams. Bye-bye.